Meet Abi. Like you, he's a chem student. Like most of you out there, he too struggles with understanding chemistry. There are different chemical structures of atoms and elements. They are involved in the following bonds: ionic networks, covalent lattices, covalent networks, and metallic structures. Ionic networks is another way to say ionic lattices. Ionic compounds form a crystal lattice that consists of cations and anions. It is a three-dimensional lattice that is held together by strong electrostatic attractive forces. Some properties of ionic networks is the high melting points due to the strong electrostatic attractive forces, and this also contributes to the hardness and brittleness of the compound. When a force is applied, the layer of ions move relative to one another, and when the like charges are close to one another, they repel, and this causes the crystal to shatter. Covalent lattices. While most covalent substances exist as individual molecules, there are some that exist in three-dimensional structures known as covalent network structures, or also known as covalent lattices. In general, substances that have a covalent lattice are very hard as the atoms are held firmly in a fixed position in a network. A lot of energy is required to break these bonds. Covalent lattices. Examples: diamond. Carbon atoms in diamond bond with each other to form a continuous 3D covalent network structures. There are no London forces present, only covalent bonds. Silicon dioxide also forms a covalent lattice similar to diamond, with each silicon atom at the center of a tetrahedron, which is covalently bonded to four oxygen atoms, and each oxygen atom is bonded to two silicon atoms. And as a result, there is strong covalent bonding that exists as a continuous 3D covalent lattice. Covalent networks. Covalent layer lattice is another type of covalent network. For graphite, the carbon atoms are in layers where the covalent bond is only between atoms of a particular layer. And this means that there are dispersion forces between the layer networks, making it weaker, hence the difference in physical properties. Metallic structure. Cations are arranged in a closely packed 3D network structure. They occupy a fixed position in lattice. Negatively charged electrons are free. The electrons come from the valence shell only, and the cations are held in lattice by electrostatic attractive forces between cations and delocalized electrons. This bonding extends throughout the lattice. Firstly, electronegativity needs to be explained. So then, what is it? Electronegativity is the ability of an atom to attract electrons towards its cells. The more strongly the valence electron of an atom are attracted to the nucleus of the atom, the greater the electronegativity. Therefore, the greater the core charge of an atom, the greater the electronegativity. Core charge is the measure of the attractive forces felt by the valence electron towards the nucleus. In atoms with two or more shells filled with electrons, the attraction between the nucleus and the valence shell is reduced by the repulsion between the inner shell electrons and valence shell electrons. The formula for determining core charge is as such. As we can observe from the top right hand corner of the animation, we can observe that francium has the lowest electronegativity of 0.7, while fluorine has the highest at 4.0. Referencing is beside it, the figure. So then what role does electronegativity play in determining the ionic or covalent nature of bonds between atoms? When the electronegativity difference is above 1.7, an ionic bond occurs as the metals usually have a low electronegativity while non-metals a high one. When the electronegativity difference is below 1.7, it's a covalent bond. Chemical bonds fall between the spectrum of pure ionic and pure covalent. Most chemical bonds fall in between the two and hence are given the name polar covalent. The Pauling scale is used to determine the electronegativity of an atom. The electronegativity difference for polar covalent is somewhere between 0.5 to 1.6. For nonpolar covalent, it's around 0.2 to 0.4, and for ionic, it's above 1.7. Ionic bonds. They occur when the electronegativity is above 1.7. They are made up of one metal and one non-metal ion. It involves the transfer of electrons from less electronegative metal to more electronegative non-metal.